Hello everyone, welcome to the Machine Learning Basic Series video. Today we are going to learn about population versus sample. This is a very important concept in machine learning. Okay, suppose there are 12 students in a class or in a school, let's say, and there are different groups, right? The blue group contains how many? 1, 2, 3, 4, 5, 6. There are 6 students from blue group. There is brown and then there is orange. Okay. Brown, there are 2 students, and orange, there are 4 students. So we have 12 students. If I have to take inputs from these 12 students, right? And let's say that I have constraints like time, and I choose to take feedback from only 3 people, right? Let's say I have to take feedback from 3 people. Who are those 3 going to be? That is where the concept of sample versus population comes in. That is, you have a larger data set. Due to constraints of time, cost, and other reasons, you cannot take inputs or feedback from everyone in your population. You have to necessarily take feedback only from few people. That is where the concept of sampling comes in. You might have seen about opinion polls, right? Opinion polls are conducted, for a large country like US or India, and then they say that, a particular party is likely to win. How are they saying that? They are saying that based on feedback collected from a fraction of the total population, right? They will take feedback, opinion polls, people who conduct opinion polls, they will take feedback from just 1% of the electorates or even less. In many cases, it is even less. And they make inference about the entire population. That is, they evaluate the feedback provided by less than 1% of the electorates in a country and say that a particular party is more likely to win compared to the other party, right? This is what happens in opinion polls, right? Now, opinion polls, how do they do it? They leverage the concept of population versus sample. So the same thing plays out in the world of machine learning also, right? Let's say you are developing a machine learning algorithm to detect, let's say, a particular disease. Okay, you are developing a model for disease prediction. This is the machine learning model that you are doing. Diseases is applicable to the entire world, right? However, your data set, how many people are there in the world? 6 billion or 8 billion, right? Let's assume 6 billion people are there in the planet. Okay, I don't know the exact number. Okay, so 6 billion, I think, is a reasonable number, reasonable assumption to make here. So will I take input or data from all the 6 billion, right? Do you think it's humanly possible? One, to collect, right? And then to store it and then analyze. All these things are a lot of, they will take a lot of time, and it will call for a lot of cost. It is not practically possible to have data from 6 billion population. Instead, what I do, I take input or include the data points only from, say, about 100,000 data points, right? Where is 100,000? Where is 6 billion? And please note that data may not be available with 6 billion population also, right? Data is available only for particular segment of customers. Let's assume for a moment that we are trying to predict heart disease, right? Let's assume for a moment we are trying to predict heart disease by collecting data from 100,000 uh, of people. Okay, not 6 billion. I take inputs only from 100,000. I analyze the data and then I make the prediction, and I say that I have developed a model. I have developed a machine learning model that can be taken to the entire world. So what concept I use? I am using the concept of population versus sample, right? So please keep this in your mind. So when I take sample, there are two things that I need to ensure. One is representativeness, okay, and the randomness. These are the uh, two factors that needs to be taken care when it comes to sample. What is the random sample? Let's say that I have to take feedback from three people, right? That three could be 1, 2, 3, 4, 5, 6, any one of the 12 people. So each one has an equal chance, to be picked up for providing feedback, right? So each of the elements in your population has an equal chance. That is known as randomness, right? What is representativeness? That is where this percentage contribution comes, right? So this is an absolute number. If I express it as percentage, how much is it? 6 by 12. This is 50 percentage, right? This is 4 by 12, about 33%, right? And the remaining 17% comes from brown. So when I take, when I create a sample out of this 12 members in a population, I need to ensure this 50, 17, and 33 is taken care. That is known as representativeness. Coming to the disease prediction population, right? Out of 6 billion, majority is Chinese, right? Next comes Indians. Next comes, other ethnic groups. For example, Caucasians. So many other ethnic groups comes in. Why am I taking ethnic groups instead of country? For example, here I am not restricting only to China. I am talking about Chinese who are widely prevalent, widely, in countries like Singapore, Malaysia, Thailand, Vietnam, and such countries, right? Chinese ethnic group people are staying in not just in China but in many other countries, right? Why am I taking ethnic group? Because disease prediction has got a correlation to ethnicity, right? Some ethnicity or some race have higher propensity for certain types of disease, right? In fact, I can expand this Indians to say South Asians, right? South Asians as a genetic group has a higher propensity for heart disease, right? Let's say that I develop a machine learning model only with Chinese and Caucasians. It won't work, right? In fact, that machine learning model will fail because it excludes South Asians. As I said, South Asians as an ethnic group or a race has a higher propensity for heart disease. Like the different ethnic groups have higher propensity for different types of diseases, right? South Asians have lower propensity for, say, cancer, right? So this factor must be taken into account while sampling also, right? So that is where the representativeness comes. One is randomness. All I am saying is don't create a bias, right? If let's say I have to pick 3 people out of this 12, right, to take feedback about a particular school, if let's say 1, 2, and 3, if these 3 students are staying near my house, it is very easy to take feedback from these 3, right? So I am introducing bias. That is what I am saying by randomness. So when you are collecting sample, when you are deciding on the sample, you must ensure both randomness as well as representativeness. Only then your machine learning model will have higher accuracy. Okay. You can deploy the best of algorithms in the world, but the models, what will ensure a higher accuracy is this, right? If you are developing a disease prediction model, are you taking care of the percentage contribution of Chinese ethnicity, South Asians ethnicity, Caucasians ethnicity, so on and so forth, right? If you don't take care of that representativeness in your sample, your machine learning model will fail. You can extend this concept to any scenario. Please note that it is humanly not possible to take feedback from your entire population. Not just the world population, but even the population that is relevant for your machine learning study. Right? Let's say you are analyzing which of the customers are more likely to churn. Right? Let's take the example of churn prediction. Here, we are talking of just 50,000 customers. I'm just giving an example, right? But 50,000 customers may not respond to the kind of details that you want, okay? Maybe only 5,000 customers. So you are going to analyze just 5,000 customers, right? You want to take feedback about, a customer's propensity to churn, right? You are actually going to ask the customer, and then you're going to build machine learning models, right? If you send a survey, 50,000 will not respond. If you say that, go and send a mailer, can you give me time, we will call you up and take feedback. 50,000 will not respond. Maybe it is 5,000 or it is even less. Maybe it is just 500, right? In such a scenario, is representativeness and randomness taken care? You need to ensure that. If you are building a machine learning model, it is your responsibility to ensure this representativeness and randomness, right? In fact, one of the biggest reasons why the accuracy takes a beating is the aspect of representativeness and randomness, right? This is a concept in the world of statistics, right? We are borrowing this concept to machine learning. Okay, a very, very important concept.